All right, class.
Yes.
All right, thank you. Thank you. I almost heard that. All right, I know you said it. Good. All right. Anyway, okay. So limits, continuity, rates of change, tangent lines, and sensitivity. Now, sensitivity is just a method of using what we're doing here. Okay, everything that we do in calculus is actually based on the rate of change, which the rate of change is just a slope. It's just rise over run, but depends on what equation we're talking about. And a couple other things that we have applications of that. So rates of change, tangent line, sensitivity. Now, geometry. Geometry. What is a tangent line? It's touching.
Yeah. It's like barely crazy.
Okay. So if I had a circle like this,
And you put a line.
that's my radius, right?
Um,
Okay. And the tangent line would be what?
the outside of the circle and the circle. Yeah, that line.
And it touches at
That certain point of the circle.
1 point. Only 1 point. Okay? Only 1 point. So that would be a tangent line. So touching the curve only at 1 point. And another thing that we're going to talk about, which is not on here, the secant line. Secant line touches at 2 points. This one right here is my secant. That one's the secant line. It touches at 2 points. So it goes through my curve and touches at 2 points, where the tangent line touches only at one. And because why not? The normal line is perpendicular to the tangent. So from there, okay, if I had my radius on my circle, it's going, this is also a perpendicular to the tangent, but on the inside. But on the outside would be the normal line that's perpendicular, and that means that they are coming together, forming a 90-degree angle, a right angle. So we have a normal, a tangent, and a secant. Yes? So how do you think I would find the normal? If it's related to the tangent, right? It's related to the tangent, right? So if I could find the tangent, this one right here, the slope is going to be perpendicular. Now we talked about this a little bit. So if the slope is perpendicular, how do I know that the slope is going to be perpendicular? So if I had, let's say if my tangent had a slope of 2, what would the normal slope be?
1/2.
Almost.
-1/2.
-1/2. It's opposite and reciprocal. So it'd be -1/2. So if I can find the slope of the tangent, that's going to help me with the slope of the normal. Okay, the tangent determines the direction of a body's motion at every point along its path. Average rate of change is a quantity over a period of time it takes, the amount of change divided by the time it takes. In general, the average rate of change of a function over an interval is the amount of change divided by the length of the interval. Also, the average rate of change can be thought of as the slope of the secant line to a curve. Did we just talk about secant? Yes, we did. And secant touches at 2 points, right?
Yes.
Good. Okay. So if it touches at 2 points, find the average rate of change from here. Average rate of change. Okay, so now, these two right here are my intervals. Say yes.
Yes.
Okay, those are my intervals. That means that I'm starting at what?
-2.
-2 on what axis?
The x-axis.
X-axis. And I'm going to?
Y-axis.
No. I'm going to what? 4 on the... It's still x-axis, right?
So
Okay.
domain.
Yeah, so that's what it means. Over the interval. Now, this should be key. If you notice, it has brackets there, right? And brackets means that it is including that number.
Close circles.
Yep. So I'm going to call this is just my f of x. And I'm going to establish the way that we're going to do this. So I'm going to have that the y value, wouldn't the y value just be f of the x value? Maybe? Yes?
Yeah.
Does that make sense or no? If I plug in -2 here, that means that that's f of -2 is going to give me my y value. Does that make sense or is that nonsense? Denny? Did I lose you there? No? Okay. So what I'm going to do here is I'm going to say my slope formula, which is normally just y1, no, I'm sorry, y2 minus y1 over x2 minus x1. So the y from the second point, and that's going to be in the end of my interval, is going to be f of 4 minus the y from my first point, which I don't know what it is at this current moment in time. It's going to be y from my first point, so that's going to be f of -2 all over x's 4 minus -2. Yes? If you guys lost, I need you to speak up now.
My brain hurts.
This is going to get crazy in a moment.
Did you get the number?
Would I get the what?
So the top part,
Those are my y's, right?
those
Okay. So now, to figure out the coordinate of this, let's go off over here. So f, wow, that was horrible. Just as bad. F of -2 is equal to 2 parentheses -2 close squared minus 3 times -2 plus 7. That's how you get the y value, by plugging in your x. Yes?
Okay. So you took the two x coordinates and you plugged them in.
Everywhere that there's an x, so f of -2 says everywhere there's an x, I'm going to plug in -2 now instead of having the x. So that's going to give me -2 squared is 4 times 2 is 8. What's that going to be? 8 plus 6 is 14.
Okay, so f of x is like the y value.
Yes.
Okay.
Yes, I want to find the y value because that's what my slope formula is. y2 minus y1. So where was that? So I was 4, 8, 14, 21. My other one's going to be f of 4. And we're evaluating here. Meow meow. You good there? I'll put you zoned out for a minute. You got it? What'd you get for the f of 4 then? Anyone get it yet? 27? All right. So is it plus or minus here? Minus 27 because there's a minus sign right here. Minus 27, so minus whatever I had there. Over 4 plus 2, 6. So this is going to give me a negative 6 over 6, which is negative 1. Questions? Hopefully. You guys, maybe?
All I know is that that's Y, so that's where the Y.
Yeah.
Okay.
So we get the value. So I'm setting this up in a certain formula here. So f of 4 means that is going to be my y value. F of negative 2, also my y value. And all this is based on this. It's all based on the slope formula. Tangent to a curve. In calculus, we often want to define the rate at which the value of a function y equals f of x is changing with respect to x at a particular value x is equal to a to be the slope of the tangent to the curve y equals f of x at x equals a. The problem with this is that we only have 1 point and our usual definition of slope requires 2 points. So, because of that, start with what can be calculated, namely the slope of a secant through point P and a point Q nearby on the curve. Find the limiting values of the secant, if it exists, as Q approaches P along the curve. Define the slope of a curve at P to be this number, and define the tangent to the curve at P to be the line through P with this slope. Whole bunch of stuff. So I'm going to have a function that says y equals x squared plus 2, and we're going to find it at x equals negative 1. Now, I am going to sketch a little graph because it makes my life a whole lot easier if we have a visual on this one. There was a visual in the notes, but their graphs suck.
I feel like for this.
Yeah, it doesn't work very well on my, my smartboard here though. Yeah. But I usually input them into the notes, but kind of got sidetracked this morning. So I'm going to graph it, x squared plus 2. So let me see. That means my y-intercept is positive 2. X squared, that means it would be here, here, and then let me see. If I put in 2, that is going to be 4. That's going to be 6. 1, 2, 3, 4, 5. Here. So here's what my graph is looking like right here. And the point that I want is x equals negative 1. That's this point right here. So I'm looking and I'm trying to find the tangent where it touches at that single point right there. The slope of the line at a singular point. So far we've done secant lines, which actually has 2 points. Right now we're going to try and use that information to try to find what it is going to be.
What is what?
the slope of the line. I'm going to have to, but we got to find it at that point. Okay, write an expression for the slope of the secant line. Find the limiting value of the slope as Q approaches P along the curve. So I believe this one they're calling this point P. And so this is where I'm going to go really off script here. So what we're trying to do is we're trying to get new color. We're trying to get basically a secant line that's going to look like this, that is going to be the same as this. But from here, this point to this point right here, is going to get closer and closer. I'm going to call this H. And I want this to go close to 0. I want this value to approach 0 because I want it to be exactly at that. So for my formula that I am going to write out, a definition of this, I want the limit as H approaches 0 of my function f of x, and then for my function right here, because it's going to be between 2 points, it's going to be f of x, and then I'm going to have this value here and this value here. So I'm going to squeeze this as tight as I can as my h is going to get closer and closer to 0 on my secant line. So from here, I'm going to call this, let's see, this point is going to be f of
So much sidetracked.
like I said, I'm going super off script on here. I'm going to make this one nice and big so we can see this. So for this right here is going to be my x and my f of x. Does that make sense?
Is it the point?
It's the point
Okay.
x, comma, f of x. It's my x value and my y value, right?
Yes.
Okay. So what I'm trying to do is I'm trying to recreate this, my slope formula. y2, actually, let's not use y's. Let's use f of x2 minus f of x1 over that. Make a little bit more sense. That is my slope formula, but I'm just writing it as functions instead. So instead of saying y2 minus y1, it's now going to be f of x because it's going to be some value from my function. Maybe? Yes?
Yeah, I do.
Okay. Now, going from here, let me change of colors now, because this is where the change happens, to right here. So I'm going to say from here to here, is h. Here all the way to here is h.
Okay, that's H. So
I'm adding h, okay, because I'm eventually going to get this line through here. So I am defining a limit here. So from here to here, I'm adding an h. So what do you think the coordinate right here is going to be?
also X sub 2 or be another.
Nope. You use the information given to you. If we're starting here at x, this one here is going to be, think super basic. No. How about x plus h? Whatever this is,
Whatever X is.
I'm just adding this, right?
Because it's the distance. Right?
Yeah, and that's whatever distance I'm adding there.
So that's where that one.
Okay, comma. So if this first part, if my x value to here is x plus h, what do you think my y value is going to be here?
Y value.
How would I write the
F of X plus H.
f of x plus h? So this is defining a limit function, because as we do this, it's going to be x plus h for the second one, and the next one is f of x plus h. So whatever value I had here, I want to have the same thing over here plugged into my function. So let's go ahead and rewrite it as the definition, because I'm changing my slope formula now, right? I'm changing my slope formula. So now f of x for my second point is going to be what?
Okay, hold on. X.
F of x plus h minus over minus what?
X.
There you go.
Yay.
Now this is super. That's a definition of finding a limit at a point. Because I want h, I want the limit as h approaches 0. I want h to be super, 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 super small. So small that it is on top of my other x value. So I'm finding it the limit as that is getting close and close to my x. Because if I have a secant line, I have 2 points. But I want the distance in between my 2 points to be so close, it's going to be 0. So I'm taking the limit as that the separation is going to be 0 there. So I have that super close to each other to the point where I could already just say it is going to be just 1 point. So now I'm going to have the limit as h approaches 0 of f of x plus h minus f of x over. Now, let's look x plus h minus x. What's going to happen down there in the bottom? It's going to cancel out. It's going to cancel my x's, right? I got a positive x, negative x, right? So if I were to do that, I'm going to have f of x plus h minus f of x all over h. Now, hopefully someone noticed the problem I have with this one now. when I'm evaluating a limit, what's the first thing I should try to do?
Evaluating a limit.
What's the first thing you do? It's the easiest thing to do. Nope. How about just plug in the number?
Oh, you want to plug in 0? As h approaches 0, you would have to.
Yeah, whenever we've been doing the limit so far, the easiest thing is just plug in the number as h approaches 0. Now, is there a problem with that in this case?
Yes.
What is my problem?
It would become undefined since h is the denominator.
Yep. It's going to be undefined at that because I cannot have 0 in the denominator. So this right here, it's going to be approaching 0, but not fully going to be 0 yet. Okay. So I'm gonna use this to try and figure out what it is. So it means I cannot plug in 0 directly. So going back to this, I have my f of x is x squared plus 2, and my x equals -1. Right? Okay. So I'm going to go back to my problem. So it is my f of x is x squared plus 2. Yes? And I want to find when x equals -1. Yes? Okay. So when x equals -1, I had a coordinate. It was -1 comma what?
3?
3? Was it? You guys agree?
Yeah, 3.
Yeah, 3. All right. Let's use that information. Use that information here. And we're gonna plug this in to this over here to make my life easier. So now when I plug this in, and I'm using f of x plus h, what am I going to replace every x value with?
-1. Wait.
No. If I'm plugging in x plus h, what is f of x plus h? Every place that there's an x, I'm now going to replace it with x plus h.
Oh, okay.
So I'm going to do that here. So that's going to be, let me see, parentheses, and then parentheses again, x plus h closed square plus 2. That is my f of x plus h. Minus f of -1. There we go. Running out of ink. So that's just going to be my... Come on now. You know what?
It's just the right side.
It's just f of x. And then right here is going to be just over h. Now, I'm going to go ahead and replace f of x with just 3. Because that's what this is, right? 3.
Okay, so f of x.
Is this your y value?
Yes.
Yes, that's your y value. Okay? F of x. F of x is what?
F of x is 3.
Okay, so I could replace all of this with
3.
3. That's what I'm going to do. And I could replace this x out here with what?
1.
-1. So open parentheses. So it's -1 plus h closed squared plus 2 minus 3 over h. Now right here, I'm going to expand that. So the -1 plus h is going to give me squared. Okay, I'm going to use distribution or whichever. Actually, having two squares is going to be 1 plus 2 minus. There's a formula for this one. Minus this times 2. 2h plus h squared plus 2 minus 3. All this right here is taking this and foiling it. There's a process to this where it is a plus b squared turns into a squared plus 2 times a times b plus b squared. I don't know if you guys remember any of that. Yes, no, maybe. I think there was a flashcard on that one too.
No, I don't. I've never seen that.
Never seen that before?
No, we usually just do foil.
Oh. You must have had Hagen.
Yes.
Okay, yeah. No, because that's super, like one of the things that, like a mental math type thing that you would do. You could simplify a lot of your expanding or your factoring, like the one that we did earlier for the warm-up, was it x cubed minus 8? That one? That's a actual difference of cubes formula. So those are things that you should just be able to pick out from different things. But I'm not making you guys, because you might have had Hagen, so you might not have actually learned any of that. I'm just ripping on Hagen, just so you know. Yeah, I know he actually goes over it because I've seen his notes, because we used to teach the same thing, and I know he goes over it. So, but some people fall asleep or stare at the phone, and all this is going to be over h. Now let's go ahead and combine. I have a positive 1 here and a positive 2 here. What's that going to give me?
Wait, hold on.
Positive 1 right there.
Okay.
Positive 2 right there.
Positive 3.
Minus 3 right there.
0.
So all those come out to be
0.
So all those together leave me with 0. So as I bring this down, I'm left with -2h plus h squared over h. Is there something in common in the numerator?
H.
They both have an h. And so I'm going to say F that. Every time you see something like that, you should say F that. Factor. See what I did there? Factor. You could take out a common h, right?
Yeah.
So if you take out a common h, you know you're going to have h parentheses -2 plus h closed over h. And what's going to happen to those h's on top and bottom?
They're gonna reduce.
They're going to cancel there, right?
I thought you can't use the word cancel.
Since when?
You said it last week.
Did I say we can't cancel? Don't say cancel.
You said reduced.
Reduce?
Yeah.
Did I say not to say? I don't know. I just got canceled for that. Okay. There we go. Now, okay, if you guys remember, when I was able to cancel it out, now can I do my limit? Now can I do the limit as h approaches 0 of -2 plus h? Now, can you plug in the 0?
Yep.
Yes, we can. We can plug in the 0, and we're left with what? -2.
All that just for that.
It's actually, it's not as long and hard as it looks. I just went super slow because some people are falling asleep while I'm talking to them. This process, couple things that trying to get you guys to remember as we're going over like this thing here. And I made a definition of a limit, which this textbook did not. They go into it later on, but it makes your life a whole lot harder by not having it right at the beginning. So, going back to this, so we got the expression, and now when x is -1, the slope is going to be what?
When x is -1,
Yes.
it would be -3.
The slope of the tangent line was what?
What are we referring to? Yeah.
Slope of the tangent line was?
-2. That's with the tangent. Okay.
We did all that to find the slope of a tangent line at a singular point because I wanted my h value to be so close to 0 that there was a limit as it approaches 0. So I could say m equals -2. Maybe? So this next one, tangent line, slope is -2, passes through that point, the equation of the tangent line. All right. Now the equation of a tangent line, we have a point and a slope, don't we?
Yes.
This here is a
Point.
That one is a
Slope.
So what formula do you think we should use?
Point slope. Okay.
Point slope. Very good. So it's y minus.
Oh yeah, we're supposed to remember this.
Yeah, y minus what? Yeah, which is? Yep, very good. Equals?
X. Parentheses X.
No.
No?
Got it.
-2.
Very good. -2 parentheses. Not yet. X minus -1.
Y minus.
Y minus y1 equals m times quantity of x minus x1.
Okay.
So there it is using point slope formula. So I could just leave it like that. Or I could just plug it in also. So let me see, y. Let's move this over here. So it's -2x minus 2 plus 3. Y equals -2x plus 1. So this is the slope, equation of the tangent line.
Equation?
Yeah, equation, yeah. Yeah, I'm running out of ink here.
Yeah, some pixelated ink.
Yep, there we go. So I'm going to leave off here, and we're going to pick up again tomorrow. So I hate the way that they try to do this. Yeah, Anyway, so again, that's why I went off on a... don't forget, like, share, and subscribe. Hit that notification button. Support my channel. All that good stuff.